Hello, everybody. This is Mr. Kusaj, and this is the start of Chapter 6. We're up to Chapter 6, and this is the first lesson. There's the title, Systems and Matrices. So if you remember last year, matrices, you should have a little bit of a background on this, but we'll start at the beginning. So linear system and row operation. If you remember, a system of equations is equations that happen at the same time. Like, for example, this is a system, and there happen to be three variables, x, y, and z. So if you look at this, we call this the row echelon form because you can look at the form and see that we already have one of them done, right? Z equals -2. And then here we have two variables that need to be done. And up here we have three. So if you look at the coefficients only, okay, if you look at the coefficients in front of the variables, 1, -1, -2, 1, -4, etc., this is what we get. So if we drop the variables, these would be the numbers left over. So I put a dotted line here to show that this was the left side of the equal sign, and this is the right side of the equal sign. So you could actually read this. This would say 1x minus 1y minus 2z equals 5. This says 1z equals -2. So basically, we're just dropping the variables, okay? So now we left the linear system and we are into matrices. If it's just numbers in rows and columns like that, we call that a matrix. So if you look back here at the linear system, right, we already know z equals -2. Well, we can do something called back substitution to get the other variables. So if you know z equals -2, right, plug the z into here, and then you'll know what y is. That's what I did here, right? So y minus 4 times -2 equals -5, right? You do the math, you do the algebra, and you get y equals -13. Now you have z and y. Keep going back, keep substituting back, and now you go up here, substitute y and z, right? And you'll find out what x is, and that's what I did here. So I've substituted both of these, right? There they go. And now I can find x. Do the algebra, do the math, and you see that x is equal to -12. Okay, that's called back substitution. This form, where you get to the last one and the last one is done, is called row echelon form. Okay? So, augmented matrix basically means write the equations as a matrix. So we're going to give you the equations, there they are, and you change it, right, by dropping the letters, you change it to a matrix. This is how it's done, right? So just take the numbers, put them in the correct, and it's understood that the first column is for the first variable, x. So these are x's, these are y's, these are z's, ... is for the equal sign, and these are the numbers on the right side of the equal sign, right? Notice the brackets, they come in a little bit, right, to show that these go together, okay? So this is the matrix, this is the augmented matrix that we got from this system of equations, right? Okay. So now we want to talk about doing operations on a matrix. There are three of them. There are three row operations that are, how do you say, legal, that you can do to solve the matrix, to find out what x, y, and z are. There are only 3 of them, and you do them over and over again until you get the answer. Here we go. These are the 3 row operations that you're allowed to do. First one is to switch rows, right? So these are the rows going across. You have 3 rows. So if it helps you, you can switch rows. You can put this row on top and this top row on the bottom. If that in some way helps you, you're allowed to do that. It won't change the answer. So that's the first one, switch rows. The second one, multiply. That's the other page. Let me cover it up. Multiply or divide, right? Multiply or divide a row by any number, right? So, for example, we'll get to more examples. We'll write them down. But for right now, what do I mean? I mean, like any row, you can choose to, if it helps you, to multiply by any number or divide by any number. So for example, what if I just wanted to double this row here? This would become 6, this would become -4, 14, 60, right? Multiply by 2. You're allowed to do that, okay? Why would you? Well, we'll talk about that later, why would you? But these are the row operations. We got 2 of them so far. Switch rows, you're allowed to do that, and multiply a row by any number you wish. And then you're allowed to add any 2 rows, right? So you can add these 2 rows, and you would get what? That would give you a 2, that would give you a 0, that would give you a 4, and this would give you 18. This would give you 18, right? So that's allowed, right? Adding any 2 rows, okay? And with these operations, our goal is to get the row echelon form, right? Which is this shape. What we want is 1s for these numbers here on the diagonal to be 1s, these to be 0s, and these can be any numbers, all right? That's what we're looking for. We're looking for 1s here. Why? Because this would say 1z is equal to something, and then we can back substitute and find all the other ones like we did up there, right? So we're going to get to the examples now, these 3 operations over and over again to change the matrix so it looks like this, right? You start out with something like this, and we're going to do things to it to make it look, to get it in this shape. Here we go. So let's keep the matrix that we just had. So the reason we're doing this is so we can find out what x, y, and z is, right? So how would you find out what x, y, and z is without matrices? Long process. But if you just switch to a matrix and just deal with the numbers, it tends to be a little quicker. Watch. So we look at this, and our goal is to make these numbers 1s and then these numbers 0s. The other numbers, it doesn't matter. So we want 1s here and 0s here. So how can we get 1s here? Well, let's start at the top. I noticed that if I divide by 5, which is the same thing as multiplying by 1/5, right? If you divide by 5, you'll get a 1 here. What about here? It doesn't matter what you get here. We want a 1 here. That's what we want. So I'm going to divide by 5, and this is what I get. 1, -1, -1, 7. Isn't that right? If I divide by 5 across? Okay? I didn't touch the other 2, so I just copied the other 2 rows. So now I'm on my way. I got a 1 here. Now I got to work on getting 0s here and here. I got to get a 0 here. Oh, wait, look. 1 and -1. I am allowed to add any 2 rows. So I choose to add these 2 rows. Okay? So look what I did here. Go ahead and add row 1 and row 2 and put the answers here. So 1 and -1 is 0. -1 and 2 is 1. -1 and -3 is -4. 7 and -12 is -5. Right? So I got this 0 and some other numbers by adding these 2 rows. Now put that row back and put this row back. Okay? So look what I have. I have a 1 and a 0. Oh, look, for free, I got this one. I need that one there. But it just happened together with the 0, so I don't have to do any extra work. So I move on. What else do I need? I need to make this a 0. Right? Remember what we're going for. We're going for this, right? 1's here and 0's here. So how do I make this a 0? Well, I need a -3. But I don't have a -3. Well, why don't you multiply by -3 here and then add it to the bottom? So if you multiply by -3, you'll get a -3 here, and you add it to the 3, and you'll get a 0. That's what I wrote. That's what I wrote down here, right? -3 times row 1. So row 1 times -3 and add it to row 3. So here we go. -3 times 1 is -3, plus 3 is 0. -3 times -1 is +3. +3 and -2 is 1. -3 times -1 is +3, plus 7 is 10. -3 times 7 is -21, plus 30 is 9. Right? So I put the top row back because I still need that 1 there. That's what I did with, and I put the middle row back because I want that 0 and 1 there. And now I got a 0 here. Oh, look. Nope. I don't need the 1 there. I need the 1 here. I need this to be a 0. Right? It's got to be diagonal. 1, 1, 1, and these got to be zeros. So I need to change this to a 0 now. Oh, that's easy because I see a -1 up here. So I'm just going to add row 1 to row 3, and it'll get me a 0 here. That's what I did. Oh, no, that's not what I did. Because that wouldn't work. You'll get a 0 here, but if you add row 1, if you add row 1 to row 3, if you add these 2 rows, you'll get a 0 here, but you'll get a 1 here. And we don't want to, we want to keep this 0. 1 plus 0 will be 1. But if you do -1 plus 1, if you do this row plus this row, you'll get what you're looking for. But you got to turn this to a negative. So negative row 2, the opposite, -1 times row 2, added to row 3. So -1 times 0, yeah, I got to keep an eye on the, to make sure it's showing on the screen what I'm talking about. So we're going to do -1 times row 2 and then add it to row 3. So -1 times 0 is 0, plus 0 is 0. -1 times 1 is -1, plus 1 is 0. -1 times -4 is 5. I'm sorry. -1 times -4 is +4, plus 10 is 14. -1 times -5 is 5, plus 9 is 14. So I got my 0 there. Now what? Now I need to make this a 1. And if you look, we're not going to add, right? Because that will just keep the number. We want to multiply or divide by something to get a 1 there. So, oh, look, if I divide by 14 all the way across, I'll get a 1 here, right? So divide by 14, 0, divide by 14, 0, divide by 14, 1, divide by 14, 1, and that's what I got in the end here, right? Now, what I'm saying is z equals 1. Z equals 1, and from there I can back substitute, right? Z equals 1. So I substitute the 1 in the other, right, in this one. So I get y minus 4 times 1 equals -5. Do the math, and I get y equals -1. All I'm doing is back substituting like I did at the beginning of the notes. Now I know y and z, and I substitute that in here, and I can get x, right? Do the math, and you get x equals 7. So I solved it. Now, it looks like a lot of work, but keep in mind, I'm just doing 3 operations, 3-row operations that we wrote down over and over and over again. And with a little practice, it goes pretty fast. You'd be surprised how fast it goes. Okay? So what we just did was solve this system by changing it to a matrix and using row operations on the matrix. That's what we just did. Okay? Go ahead and copy these and try. Where am I? Right here. So try these two. Okay, maybe you want to pause. The first thing you're going to do is write them as matrices, right? So they're going to look like this. So these change to this one changed to this. And now you do the 3 row operations over and over again until you get the row echelon form, right? We want one. Oh, look, you already got ones there. Ones here and zeros here. Ones here and zeros here, right? And then you do the back substitution and you got the answers. Okay. Now, we'll go over the answers when I see you in class. Okay. For part 2, if we continue, right? There's something called the Gauss-Jordan elimination. You don't have to know the name, really. If we continue the row operations, we get a what's called not just row echelon, but reduced row echelon. Okay? And what that is not only do you get ones here and zeros to the left, you get ones here and zeros everywhere else, except on the other side of the equal sign, right? So this would be the reduced row echelon. Not just row echelon, but reduced, because we get zeros up here too. So we just keep doing the row operations and make zeros up here too. So here's one example, and then we'll be done. Let me hurry, because it's really getting up there. So I'll go faster this time. So here we go. First, we get the system of equations. We change that to a matrix. There it is. Now, I already got a 1 there. I need a 0 here. Oh, just add the 2, right? I wrote it on the right side this time. So to get from here to here, you add row 1 and row 2, and you'll get this. Now put row 1 back and row 3 back. Okay, now I want a 0 here. So why don't we multiply by -2 up here, and it'll give me a -2 there, and then add it to the bottom. So what I did for here is multiply -2 times row 1, and then add it to the bottom, row 3, right? And I got a 0 there. Okay, so now I want a 1 there. It's already there. I need a 0 here. Well, that's easy. Just add this row to this row, right? So if you add row 2 and row 3, you'll get a 0 here. Oh, look, and you get a 1 here, right? -2 plus 3 is 1, which is what I need. Now, normally, we would stop here, right? We stopped, the first example, we stopped here and we said, okay, so Z is this, back substitute, and you get X and Y. But we can keep going. Now, let's make these 3 numbers zeros. How, Mr. C? Well, you're allowed to add up. How about if we add row 2 to row 1, right? If we add row 2 to row 1, we're going to get a 0 there, right? And we get a -1 and -5 there. Now put the other 2 rows back. Now, how do we get a 0 here? Oh, look. If we add the 3rd row to the 1st row, we'll get a 0 here. So that's what I did. Row 3 to row 1, and you're going to get a 0 there. There it is. Now put the other 2 rows back. Now what? Now I want, I want a 0 here. So what can we do? How do we get a 0 here? Well, it'd be great if this was a 2 to add to the -2. Well, let's make this a 2 by multiplying. So 2 times this row added to the middle. So 2 times row 3 added to the row 2. Right? And you're going to get a 0 there. Now look. Now I'm done. I don't even have to do the back substitution because everything is done. This says that, that 1z equals 3. So z equals 3. Look, everything is zeros here except for the y. 1y equals 1. So y equals 1. 1x equals -2. So x equals -2. Right? And we're done. So we didn't stop here and do back substitution on the side. We just kept using the operations to make more zeros on top here. And so we just have a 1 and a 1 and a 1, and then what it's equal to. Okay? That's it. That's it. That's how you switch, how we switch from systems equations to matrices and then solve it. So we went from this to this. We got the answers to these equations. Here they are. And we use matrices. Okay, 20 minutes. That's pretty long. Okay, see you in class. Bye.